Alright, here we are. Thanks for coming out. Today is going to be a short stream. I don't... Those of you that know me in person know that I have been, not on top of my life for the last 2 or 3 weeks. And this will continue to be the case until, after Mystery Hunt, probably. And probably after that as well. But... here we are. We're live. It still says rerun? Oh. Maybe I should change the title. Okay, let's see. Okay. So do people want to play the new FTW? I want to feel silly doing so. I was like, oh, FTW is gone. I don't have to play anymore. But now there's a replacement, so... Thank you 3VT for the cheer. Alright, let's play a bit of... let's play with UFTW for a little bit. Just for comedic value. Alright, how do I use this button? This is gonna take me a while to get used to. Alright, so I press this button. There's no more 1v1 countdowns. I guess there can be 1v1 FTWs. Whoa, wait. I didn't press start. What? Okay, why is there a buzzer? Oh, thank you, Nuke Launcher, for a 5-bit cheer. Why is there a buzzer? What, like... Okay, whatever. That's fine. Why does my num key know? Okay, so the number pad doesn't work for me. That sounds not good. So, it's gonna take me a while to get used to. So once you press the buzzer, you have 5 seconds to submit. Does it count? Okay, I didn't answer it in 6 seconds for sure. So you now have to press the buzzer before. The strategy is to press the buzzer 5 seconds before you get the answer. This is okay. Well, here we are. I'm sad the number key doesn't work. That seems like, really? Why would it not work? Oh, because my num lock is off. Okay, that's a good reason why the num key might not work. Yeah, now you just have to smash the buzzer faster than the others. Oh my god. This is... I don't like this do buzzer thing. I liked it better when I could just type the answer. A question like this, you just press the buzzer right away, right? You don't wait. Alright, we are playing with the new FTW just for comedic value. After that, we're going to get back to math. It's a short stream today because I had a meeting for Mystery Hunt right before this, and I will be continuing to do Mystery Hunt stuff for most of my waking hours for a while. Probably not, actually. I should... Oh, jeez. The trick is really hit the buzzer and then take your time. Do alter player. Oh, was there a player limit? Oops. Okay, we'll do one more after this so that more people can play. Yeah, come to Mystery Hunt, it's gonna be lit. We have such a great hunt ready. Oh, jeez. Oh man, that was a lot of problems. Oh, I never refunded the requests from. Okay, so you're saying there's a player limit this time? Oh, I didn't see that at all. $99. Oh, it doesn't go beyond 20. Okay, that's reasonable. Yeah, no more massive. Alright, everyone loaded in? Oh, frick. Ah, this is one I... Oh, that was a mistake. Rip. F. Man. I've sounded a bit stuck that 109 thing. Okay. I kind of missed it. Alright, well, now we're super behind. Oh, crap. Oh, that was a mistake. Wow, this game is not going well. Jeez. What did I mess up? Oh, okay, I know what I messed up. Thank you, QQEEAAZ, for the sub. What does that red badge mean? Why do I have a red badge? Hit the buzzer faster. Wait, what? Oh my god. What? Did I need to type the percent sign or something? I forgot what the question said. I got it right? Okay, whatever. Oh, I need to get it right. F. Oh, it's not perimeter anyways. Okay. Ugh. That was bad. Okay, one more. Man, there's no more chat. I think that's good. I mean, you press the button and then time stops. Okay. Oh crap. 35. Would you consider making a stream where people can request problems you've done but you have to explain solutions live? I would consider it. I don't feel super excited about it. I think that for the problems I do, I usually write them up nicely and post them anyways, so it's not clear to me what you would get out of the stream. But well, there goes my rank. Actually, it's not as bad as I thought. Probably could have buzzed a little sooner. I mean, 0.5 seconds is very reasonable in this new FTW. You just hit the button and solve a problem in less than 5 seconds. Like, 0.2. For me, the problem didn't load on the screen in time for me to press the buzzer. I thought you didn't like lightning? No, I don't like lightning. That's why I said this is more stressful than the old one. You have to like make a bet on how quickly you can... 5 seconds? Wait, what? No, the buzz time is 5 seconds. That's how MathCounts works. What? Oh, I said if the question is easy, you hit it immediately. Like, just now the question didn't load for me, and so I don't know if the question is easy. Isn't the meta just click and hope you get an easy problem? I don't think so. I don't think there's I don't think the fraction of easy problems is big enough for that strategy to work. Right, because if you, especially since like if you get it right, you only get like maybe some number of, you get like maybe +5-ish in a game this large. But if you get it wrong, it really hurts to get questions wrong. Hey. See, this is what happens when you're overconfident. Wow, I might actually be... Yeah, I'm gonna like overtake 2 places because like if people look at it, they think they can get it quickly, and then what is oh crap. Lame. Yeah, it's buzz time. I mean, this is how it is in actual MathCounts. So if you want to practice MathCounts countdown, like, this is how you do it. Alright. Oh, crap. Hey, we did it! Should have buzzed it. I just a bit earlier, yeah. Alright, Islander definitely wins, but... Isn't MathCounts countdown irrelevant? I don't know if that's true. It depends on the state. In California, it's irrelevant. Thank you, Brian ZGK, for 8 months. There's a really nice format for countdown where you take the top like n people, and then person n competes against n-1, and the winner goes on and competes against person n-2, and so on all the way up to 1. So your rank can fall by at most 1 as a result from the countdown, but it could go potentially from n all the way to 1. Tenth to 3rd. Yeah, this is I believe the documentation is that if you want to have an official MathCounts countdown, it has to be that format. Alright. Let's get back to math. So I only see 3 problems, one of which is an inequality. Was there a request that I accidentally rejected or something? Doctor. Me close. Oh frick. So Andrew, I think I accidentally rejected your request. If you could resubmit it, that would be great. And when true. Wow, it's an inequality. Square 8, 7, 12, 6, 5, 3, 4 mentally. I don't think I have the bandwidth. Like, I can remember up to like 7 or 8-ish digits at once. Eight is a stretch, honestly. Even eight. So, no. Yeah, today is stream 48. All right. Oh geez, computational geo. Okay, let's see. What else can I... What else is on the request queue? I'm not bothering with Lester. That's like never made it. 1994 C4. Is this A cube, B cube, C cube thing a joke? What is this? Okay, alright, whatever. Alright. Okay. Really? You have enough to suggest a poll and this is what you pick? Alright. We'll put this poll up while I'm still copy pasting the prompt statements. What's 5% more than -1? Minus 1.05 minus 0.95. I'll take it. If that's what you want to spend your hard-earned shadow points on. Okay, that's all the ones that are serious. Oh yeah, speaking of which, we were going to make a reward for yeah, how much should I set for do a problem intro? What is So, for Brian's UHK, yeah, so recently I've been like actually introducing the problem on YouTube because apparently some people think it's important that I start by saying hello and then reading the problem aloud. That was and someone said that it would be a good reward for someone else to get to do the intro. So I don't know. I'm gonna make it a reward, but I don't know how much to make it cost. Oh, is it tied? Wow. Alright, well, I'm going to cast my vote. Like... I think the other option might still win. All sub-votes are worth 3. Yeah. Yeah, sub-votes are worth triple. Alright. Alright. 0.95 wins. F. I think it should be minus 1.05. But that's fine. Alright, meanwhile, we are going to add a new... I find this really silly. Like, this is the interface for adding rewards, and like, you can upload your own icons, but they give you like some starter ones to get started. And the way that you get to... It's like you make me download a zip and then like re-upload it. Like, why can't I just... Oh, it doesn't even work. Here. Or there. That's also not what I wanted. There we go. So I need to like download a zip, extract the files, and then upload them, re-upload them. It's like... Well... Alright. Do a YouTube intro. You get to... pay me the effort of having to read the problem aloud for all to a video intro. For all the YouTube viewers. And this can be worth a lot. Create. Dun da da! Yes, I got some more green back there. Okay, anyways. Alright, problems for today! Alright, which problem? Alright, have at it. That's so even. Why no 8-digit squaring? Shrug. Oh my god. I'm not sure how I feel about these poll results. Right. Alright, it's inequality day. So, Geo. And then CMIMC, SLC4. Alright, give the people what they want. People want inequality? Okay. Okay. So should I do a Ravi substitution or what? Oh, actually, wait. I forgot something important, which is the YouTube intro. Okay. Let me first make this align so it looks better. I've been scoring 8-digit numbers when, like, if I can. The problem is I can't actually do it, which is why it's like, I don't know. Anyways, all right, let's do the YouTube intro. Hey everyone, welcome back. For today's stream, viewers voted on a collection of various problems. You know, this was the collection they voted on, and the one that came out on the very top was the following inequality. In triangle ABC, proves that a cubed plus b cubed plus c cubed minus 3abc is between these two things. Yeah, so that's the problem we're doing today. I hope you like inequalities. So, yeah, so here little r is the in radius of the triangle and capital R is the circumradius of the triangle. We're gonna start by just factoring it because, I mean, I don't know what else to do with that. A cubed plus b cubed. Read the things out loud. Okay, fine. Left hand side, 8 little r times capital R minus 2 little r times open radical little r open bracket 16 capital R minus 5 lower r end bracket end radical, when right hand side 8 capital R times open parentheses capital R minus 2 little r close parentheses times open square root times open bracket 2 capital R plus little r close bracket squared plus 2 little r squared and square root. Yeah. Thank you for generating more clip content. Oh yeah, also there's a 1/2 that I forgot. Okay, so this is the semi-radius, or semi. I'm going to. This is the semi-perimeter, and this is like I kind of want to do a Ravi sub. I don't know if it'll make things better or worse. Yeah, I mean, I think that's the XYZ thing is fine. I just don't know what I'm gonna do with these arts later. Like, little r is actually not terrible. Like, little r can be written explicitly in terms of stuff. Capital R is pretty bad. So if you want, the explicit forms are the end radius is equal to the area divided by the semi-perimeter, and the area is like being given by Heron. Alright, so let me do the substitution now. X is as xyz equals the s minus a, s minus b, s minus c. So sy plus z is equal to s. And like a is equal to y plus z, etc. Yeah, 16r minus 5. So little r is okay. It's equal to this, if anyone's curious. But capital R is not as good. It's actually, it's not horrible either. It equals this, I think, if I didn't mess up. I hope. Yeah, so like individually these are not horrible, but I don't see any way that I can like do anything with this. Actually, okay, one thing that I think is worth mentioning is that capital R and little r actually subtract okay. So like the ratio capital R against little r is like rational, actually. So one thing I can say is that it's like this is equal to x y or plus z. So this is a true statement, I believe. Is there any way to use the fact that OI squared equals R times R minus 2R? I don't see one. I had the same thought for a moment, but it's just OI squared doesn't seem any better. Like, because I think the form of the the expressions is so artificial, I do not. I mean, what good does it do you if it appears in the problem? Like, the problem is, like, there's no geometric interpretation for most of the stuff here, I think. Like, I don't know any way to geometrically interpret 16 capital R minus 5 lowercase r. On the other hand, I could write this as but I can write everything explicitly in terms of x, y, and z. Might want to draw a triangle and try to use Pythag. But like, what is cat2 capital R plus R? Like, that length doesn't appear naturally anywhere. Or like 2 square. Just square twice? I refuse to square twice. Okay, you know, I don't... Unless someone actually has I don't know. I'm gonna first start by factoring out stuff. And so left hand side is equal to like r cubed, little r cubed, times some constants. And those constants are x plus y, y plus z, and z plus x. So this is a true statement, right? F plus y, y, oh, sorry, this could take a while to type. So if I factor out all the instances, oh my god, it doesn't even fit. You know what? Let's call this thing k, all right? For brevity reasons. R cubed times 8k times 16k minus 5. So I guess the question is like, does 16k minus 5 do anything like at all? I don't know if that's gonna... I don't see any other way that I can move forward. Oh, I dropped the r minus 2r term. Silly me. That's not r, that's k minus 2 times square root of 16k minus 5. Maybe we can get this in terms of because a equals 2 capital R sine a. I mean, that gives you sine squared. Okay, so here's a bit of hope. 16k minus 5 might factor because in the equality case, it equals 27, which is a good number. So let's first compute k minus 2 actually. K minus 2 is... Oh, actually, hang on, that's interesting. So k minus 2 is equal to this. Does it factor? That's the question. So, plus 2 minus 6xyz. The other question is, does 16k minus 5 factor? 16k minus 5 is equal to... So I am praying that like one of these something bugs me about these expressions. I don't know what it is. I'm really praying that they factor or at least like are related to this in some way. Does this one factor? Alright, I'm just gonna ask Wolfram Alpha. Dear Wolfram Alpha, please factor random symmetric polynomials for me. No, it doesn't. Yeah, they're both irreducible. Ah, that's sad. Thank you, understand table, for the follow. R cubed. So, like, what am I supposed to do? What's the other side in terms of R? I mean, it's what it is. It's gonna be R cubed times some stuff. It's gonna be R cubed times 8 times k minus 2 again. And this time, the other side will be... Oh god, the other side doesn't... $4k squared plus... for RR. 4k plus 3. What about trig? I don't see why trig is going to help. Like, you can replace like little a with sign capital A, but it isn't. Oh, you're right. Sorry, there's 8k here. So the two sides are actually quite far apart. Like, if you ignore the k minus 2 factor, which, you know, that k minus 2 factor is only... Yeah, the two sides are off by almost a factor of 2. So I get the, like, I have the impression that, yeah. I agree the inequality is probably not very strong because the two sides differ by a factor of 2. I still don't know what I'm supposed to do, like... Is there any hope that I can try to write this thing in terms of like capital R and K or something? I just don't know if there's a way to geometrically deal with this thing. Wait, actually, now that this is true... Is this equal to like x cubed plus y cubed plus z cubed minus 3xyz? That's true, right? Or at least it's equal to twice that. God, my delay is increasing exponentially. That's like 2 area. Is it helpful for me to translate to areas? I don't see how. Okay, actually, areas might not be helpful. Because I guess the idea is something like capital R is ABC divided by 4 times the area. Little r is equal to area, all divided by a plus b plus c. It's not great. XYZ, x plus y plus z. This looks super ugly. I don't know why this problem won the vote. But here we are. Extremely nice expression between the expressions under the square roots. Wait, which thing? This one is degree 3. This one is degree 3. There's an x plus y plus z, right? Can I express Is that true? That's definitely not true. What terms is it off by? X squared, Y. Okay. That is a true statement. So we're going to try to use these three things as variables, I guess. I'm just making stuff up now. Whatever. We'll roll with it. Okay. Let's see if I can get the left hand side. So, 8 times k minus 2, which is... k is the ratio of b to a. So r cubed times a should be less than or equal to a. And r cubed is c cubed C over, is that right? Or sorry, a plus b, b plus 3c. This is some real desperate. Does k minus 2 really not factor? That's the thing that I'm most annoyed by. Like, I really want this to be like, have a factor of like x minus y squared or x squared plus y squared plus z squared minus xy minus yz minus zx or something like that. Because if this doesn't factor, I'm like, I really want this to cancel against the a and give me just like x plus y plus z. Because they're sort of like equal, or not even factor. Maybe I can like fudge it or something. Like, oh my god. Is there... Yeah, no, this is too heavy for me to possibly do it by hand. Okay, are there constants that make this inequality true? So this inequality as written may or may not be true. It's probably no, this should be true actually. No, it's false. But it is true if I scale it in some way. What scaling do I need to make this work? If I choose like 2, that's true. What's the best constant lambda that I can put here? So by putting in x equals 1, y equals 1, z equals 0, that's the place where sure kind of causes things to blow up. Lambda equals 1. Lambda should be at least 1. Oh wait, does 1 work? Let's see. The 2xyz. Oh, this is sure is inequality exactly. Oh, this is actually sure is exactly. Okay. So let's just cancel this and like cross our fingers that the resulting inequality is true. Then the inequality becomes 8r Okay, let me get this right. 8r. Ah, frick. What's the denominator? What's the denominator? So I want r cubed times square root of 16k minus 5 times 8 less than or equal to... Oh, that's a long shot. Root 16 minus 5. I missed the factor of 4. Just before x, y, z. So, okay, so 2r cubed. Now 2r cubed is equal to that. So this is true if and only if 16k minus 5 is less than or equal to times square root xyz is less than or equal to s plus y plus z to the 3 halves. Wait, isn't this just true because like k is less than or equal to 2? No, sorry, k is greater than or equal to 2. Okay, so the problem is that this k here might cause things to be... Yeah, k can be big, so we're in trouble if k is huge. However, if k is huge, that usually means this thing is very small. So now we can plug this in, expand, and cross our fingers. Okay. Alright, so there. So first of all, is this even true? So what I'm going to do is I'm going to plug in all ones and make sure that the inequality looks like it's correct. And inequality looks like it's correct because x equals y equals z equals 1 is holding. So that's very good news for us. Yeah, actually this is just going to be sure, right? I square both sides. This one has a plus 3xyz now. So all these terms are weaker than all these terms. No, there's a 6xyz here. Okay, let's find out. Okay, final showdown! It comes down to these terms. So xy is... Okay, so for symmetric sum, x squared y plus 3xyz versus x cubed plus y cubed plus z cubed plus 2 symmetric sum x squared y... Sorry, 3 symmetric sum x squared y plus 6xyz. It doesn't even fit. Oh my god. Okay, and cancel things out to get da-da, da-da-da, da-da-da, it's sure! We got sure! Alright, this is true. Yeah, it's true. Alright, we got 1/2. Alright. One more half. We got left hand side, yeah. For the right hand side, the problem is that, like, these... I don't know what I'm going to do for the right hand side. Yeah, this is actually quite clean. I think the left hand side was designed so that this calculation, like, because these constants I'm pretty sure are picked specifically so that when you do this cancellation you get sure left over. The problem is I don't know what I'm gonna do with RHS. Right hand side is because this calculation relied on comparing this thing to this thing, which doesn't work the other way around. Like, if y and z are both small, but x is large, this term will always be greater. So in order for us to have a chance of getting the other side, you need to somehow bound this thing from above, which seems really hard to do. Yeah, because k minus 2 is here. Actually, I'm surprised the right hand side is even true. Because if y equals 1, z equals 1, and x is close to 0. Oh, that causes k to explode. Why does k explode? Okay, let me think about this a little. It's possible for the other side I will want to work with... No. I think I want to really cancel the k minus 2 because this is the thing that's getting the 0. Like, when x equals y equals z, this is the term that vanishes together with this one. So I need to bound it... Oh, God. How do I get the upper? Like, what makes this side big? It's like it's because k is big. I need another XYZ here or something, I think. Okay, let me start another page. Okay. So hide some stuff that I don't need. Move some other stuff. So in order to proceed, I need a bound that will let me kill off the k minus 2 like before. So I want to compare x cubed plus y cubed plus z cubed minus 3xyz to x plus y plus z, z plus x minus 8xyz. But as written, there is no constant that I can use to make this true, because when x equals 1 and y equals z equals 0, then bad things happen. This whole side is 0. So for this to be possible, I must multiply on by some thing that isn't too terrible. So because I want to make the right hand side weak, I'm going to pick xyz. And for the left hand side, I want to pick something else. What is the thing that appears? This is desperation. This is like... So again, I want to ask, what is a constant that will make this inequality true? And for this to have any hope of being true, it's going to have to be like... Oh god, this is gonna be so annoying to expand though. What did I say our hand side was? 8k times k minus... Yeah, if I want to use the k up, yeah, here's how I use it. Oh jeez. Okay, so this is beyond what I can do by just staring at the screen. So we are going to use advanced technology called Chinese triangle notation. I used the PG-13 name, Chinese triangle notation. Because we are a family-friendly stream. God fucking damn it. Alright, so, okay, more seriously. Alright, so I need to expand. For this to work, I need this thing to expand and turn out to be something not too bad. So first I need to compute what like x plus y squared times y plus z squared times z plus x squared is. I don't actually know how you compute this. I probably should just write out all 27 terms and then collect terms or something. Okay. What is the coefficient of xyz squared? It's like 8, 10, I think. And then oh, this is so annoying. X cubed y cubed is like 2. I think there's only one way you get x cubed y cubed. I think this is too small. I feel like there's no constant that will make this. Is that true? I feel like it's too small. Because there's a bunch of 3 to 1 terms, and the 3 to 1 terms are really weak. 6, 10. So, what's the coefficient of like x cubed y squared z? Oh wait, I can look at the exponents mod too. Ha, that's genius. Okay. So I want the coefficient of x squared y squared if I take the 2zx term. And it's like just 1. There's a 2. Oh my god. Actually, there's another case where I like take, let's say like xy times yz and then times x squared. It's 4. So I think this is 6. I want to say this is 6. It has to be even. So the total is supposed to be 64. So far I have accumulated 58. So I'm missing a type of term. The 420 term. Okay. What constant do you need to make the solution work? I have no idea. I am just interested in getting a constant such that like it does anything. Like I feel like I can figure out the best constant for which the inequality is true and then see if that constant works. Okay, so that's what that is. And then what am I subtracting? 8xyz times minus 8. The good thing is the terms I'm subtracting are all very weak terms. So that's like in the direction I want. Yeah. Okay, so it kills off this. Yeah, these two will mostly destroy each other. And also I get to subtract off 6. Oh, so all the small terms disappear. Oh, that's very good news for me. Alright, so this is a minus 16xyz squared generated by minus xyz times that. That goes here. So all the small terms actually are negated. They have a negative sign, and that's really good. So here it's symmetric sum x to the 4y squared plus 2 symmetric sum x to the 4yz, or cyclic sum actually, plus, I should just, whatever, 2 cyclic sum x cubed y cubed minus 2 symmetric sum x cubed y squared z minus 6 xyz all squared. So this is the right hand side before I apply the multiplier. On the other hand, the left hand side, is, it's like cyclic sum x to the 4th yz minus, it's only minus 3 though, so 3xyz all squared. So we are interested in, I think the right hand side's bigger even just almost unconditionally. Like, it would take a very large constant for the left hand side to overwhelm the right hand side, I think. Certainly, like, even a constant of 2 would be okay. Should I write everything with symmetric sums? No, I want to keep the cyclic so I can see it. Yeah, so in particular, there is a Schur's inequality that looks like the following. It's 1 minus 1 minus... So this is called, what's sometimes colloquially called upside down triangle Schur. This is the statement that says cyclic sum of x cubed y cubed plus 3xy all z all squared is greater than or equal to the symmetric sum of x cubed y squared z. 6th degree Schur would have like x to the 6th terms, which aren't present in this problem. But here we have like x, y's, so it's sort of, the triangle is actually upside down. It's 3rd degree Schur applied to x, y, y, z, z, x is what's going to be relevant here. So even up to like a factor of, this should be 3. Even up to like a factor of 3, I think the inequality is still true. Yeah, like the upside down triangle Schur says that... Actually, what it really says is that this blob here, this blob is always non-negative. No, so I can basically throw it away. I can like not really think about it. And so... Hang on, oh, wait, that's not great. I don't want to throw it away, do I? That sounds bad. 6. Wait, what am I doing? No, 3. I'll put a 3 here. No, plus 3. Okay, let me get this right. We'll put a plus 3 here, and then a minus 9 xyz all squared. Or minus 6. Is that right? Yeah, 3 minus 9 is minus 6. So this whole bit is non-negative, and up until a factor of 3, the inequality is still true. If I put right-hand side like x 3x, the 9 will cancel out exactly, and I just get a standard AMGM, which is true by mirror head. I believe 3 is the best constant, because once I don't have something similar to high degree sure, yeah, so I can go up to 3x. I'm pretty sure that's optimal. I'm not 100% sure, but it's good enough for the purposes. I don't necessarily need the optimal constant. If what I have doesn't work, I will try to optimize the constant later. Okay, so with that, what have I proven? I've proven the following lemma. Xy plus y plus z plus x plus y plus z plus x minus 8 xyz. Well, actually, this is okay. Let me just call it what it is. This is k minus 2. And then xyz. I use x, yeah. This is true. This is what we have. The k minus 2 will give us this thing that we had all before, except I have it with even with a factor of 3. I dropped the 4 somewhere. There's supposed to be a 4 for... Where's the 4? So k minus 2 is equal to... Alright, let me do this slowly so I don't screw up. We had a 4xyz here and xyz here. So I canceled that and I canceled that. Awesome. Okay. Very good. Jesus, it's almost midnight? Oh, wow. This might be the only problem we get to today. Alright, so once I use that and throw it at the original inequality, 2xy... Okay, so the original inequality was 2x cubed plus y cubed plus z cubed minus 3xyz is less than or equal to r cubed times 8k, k minus 2 square root. So, if I use this, I can get rid of most of the heavy terms, and what I'm left with is 2/3 is less than or equal to r cubed times 2k times square root 4k squared plus 4k plus 3. Okay, and now I'll put in the value of r cubed. Evan, confirm or deny, is the bed point named after you? I am under the impression it is not named after me. Oh, this is dangerous. Okay, I'm gonna also substitute in one of the two k's because we know the k value is has that big fat thing here. I'd overflowed the page again. That's fine. Alright, sorry, let me not put in r cubed yet because nothing from it cancels anything. What I was going to say is, so we're going to put in the value of k now because it will cancel out a lot of things. Bing, ba-ding, ba-ding, and then... So I get 4xyz here, which is looking good because I want xyz is a small thing. And 3r cubed times square root 4k squared plus 4k plus 3. And if I have 3r cubed, I'll now let's put it in. Shoot. Okay, so when I plug in x equals y equals z equals 1, I get square root 27 over square root 27. I get 3 on right hand side and 4 on left hand side? Uh-oh, okay. Double check all the constants! Ah! No! No! Please don't be true. No! I thought this estimate I used was pretty sharp. You've got to be joking. Okay, this is set 2. R cubed, 8k, k minus 2. Alright. Okay, let's go back to this thing. So I use 3x. In order for it to work, it sounds like I need 4x. So let's cross our fingers that the 4 it's true with 4. Oh god, I don't think it's going to be true with 4. Well, fourth degree things have some more wiggle room. So if I want this to be true with 4, but I'm going to just write down what inequality I need to be true for it to work with 4. And we're going to not apply the sure right away because we might need something even sharper if I'm going to make this work. 1 minus 2, 1 minus 2, 1. Not minus 2 there. What's the x cubed, y cubed? 2, 2, 2. Okay, and then minus 6 plus 4, so there's a plus 6 inside here. Oh wait, no, 4 is fine. Why did I think it didn't work earlier? No, it's not fine. Is it fine? Okay, minus 2 symmetrics. Hang on. X cubed y squared z. Okay, so first of all, there's a typo. That should say symmetric. Sim. So... Yeah, 4 is okay, actually. I take back what I said. This is 6 here, right? and this can be 12. So the original coefficient is -6. This thing should be a sure, right? It's the doubling of upside down for. Okay, so I can use 4. Okay, thank God. If that 4 didn't work, I would have just like give it up. So this inequality is true with no constants. And so now I can rework all these constants. So yeah, I don't need to write the... If you believe that math is discovered rather than invented, it makes sense to appeal to God. You want statements to be true, and you have no control whether the statements are true, so you hope that whoever set the rules of this universe set them to be true. That's how it works. Alright, so it lines up exactly now when I plug in x equals y equals z, which suggests that things are looking up. So now I have x plus y plus z cubed less than or equal to xyz square root 4k squared. Yeah, where k is thingy. Okay, sorry, this should be after squaring. So on the face of it, this might be a little bit bad news, but I think it should be okay. I'm a little worried that this xyz is on the right hand side, but I mean, this inequality is sharp enough, like I would be... If this doesn't work, I am out of ideas. Like, I don't have anything else I want to try other than like full expand all like 100+ terms. XYZ is a little scary, but because k has XYZ in the denominator, I think we should be likely to be okay. Now let me rewrite what k is so I can keep track of it. It's x plus y, y plus z, z plus x over 4xyz. So then this thing, when full expanded, is equal to 4k squared. So it's x plus y squared, y plus z squared, z plus x squared over 4xyz. Plus x plus y, y plus z, z plus x, full stop, plus 3xyz. Hang on, something's wrong. Okay, degrees don't match. Oh no, this is degree 6, 3. This is all constant, this is all constant. Degree 3, degree 3. This is degree 3, degree 3. Okay, so then the first thing I should do is, like, cancel off things, right? I'm surprised there's no coefficient on... Yeah, I feel like we should be okay because the XYZ is getting moved over. Yeah, there's no more XYZ divisible things on the right hand side, so there's almost no way I think that this inequality will be false, especially since the estimate we used was so sharp. So I none cancels. So x cubed plus y cubed plus z cubed plus xyz plus sim sum Okay, so far so good. Both sides are 16 when x equals y equals z equals 1. So what should I do now? Do I just expand? I feel like we did this already, actually. This looks familiar. Is this the same thing as the one we were just doing? Not really. But the good news is that I already expanded x plus y times y plus z plus x all squared. So like we know exactly what it's equal to because we expanded it just a moment ago. Hang on. Okay, wait, no. Is this the same inequality? Well, both sides are 16. It feels like almost the same inequality again. Like it feels like it's almost exactly the same except the left-hand side I think is actually weaker than yeah, because this thing is I'm pretty sure this is the same inequality, but even weaker than before. Or it might be... No, it might be stronger, actually. No. Okay, what's the right-hand side? The right-hand side is equal to k times x plus y... Okay, so if we quote this, then it is enough that... SC2 overlay is adorable? Thanks. Yeah, I had a lot of fun designing it. So, quoting... lemma again, what needs to be true? I want 2x plus y, y plus z plus x. To be at least 4xyz plus 2 symmetric sum x squared y. This is an equality, isn't it? It's literally exactly the same inequality because these coefficients match up exactly. Oh, what a struggle. Yeah, so you like there's a reason the constants are so like artificial. It's so that like you know, it's not a coincidence that this worked because like okay, what is this Jarrett-Son's inequality that is mentioned? Jarrett-Son's. Oh, what the heck? Okay, we did it! Yeah, so that's how you're supposed to get rid of the x plus y plus z term. But I managed to cancel the entire thing somehow. So that was okay. Well, okay, fine. Fine. Alright, so that concludes the work for today, or at least for this problem. What do you think? Think inequalities are outdated? Should we do more modern problems? Do you think inequalities are coming back? Post your predictions, like, subscribe, do whatever. I don't know. Yeah, that happened. For the record, I think the lower bound for this problem is extremely fair. Like, I think, like, this part where... I think this part is, like, fair game. Because you really want to cancel the terms that are vanishing. So I think it makes sense that you hope an inequality of this form is true, and then you work out the best constant for it. And the constant is always going to be 1 because it's the best constant for which the inequality is true. And then, well, you get sure again. So yeah, it's interesting. It's really sure twice. Like sure once, sure twice, and then this one also turned out to be sure twice. So I'm really bothered by this because I can no longer tell like how the problem was created, because it seems too coincidental that these terms are exactly the ones in whatever that named inequality someone found was. It feels like it's too coincidental that you would design a problem with to be solved by two applications of sure, and then like this term would exactly line up with like that semi-perimeter thing. Anyways, just some food for thought. Alright, see y'all next time. Oh, they posted something? Alright, let me take a look at that. How do you feel about Jarrett-Stuntz inequality? I actually probably have like heard of the name before. I probably even saw like kind of what it looked like, but like because I don't do geometric inequalities very much, there is no way I was going to remember it or recognize it. So anyways. You have a question about studying? Should I ask you here or Discord later? Up to you. Alright, do I want to do any more math today? We really fought this for all 2 hours. Is this going on Otis unit? I might actually put it under hard Ineq. Like, I feel like it's a fair problem, like... Asshole C4. I don't know. The IMO. Let's do the IMO 5 because I feel like it will. Every time I say this, I get jinxed, but I hope the IMO 5 goes quickly. If not, we will. What does K represent in the lemma? It's the ratio of capital R to little r, given explicitly by this formula here. Actually, I don't think... I might be too tired. I'm like looking at it and I just see like A and B. Okay, never mind. We're... Or... We can also just rely on Twitch chat carrying. That might work. Alright. Alright, let's start. Let's just do it. Alright. Hi everyone, welcome back to another episode of Twitch Solves ISL. Today we have an IMO 5 which asks for all pairs of integers a and b such that a to the b squared equals b to the a. So, I'm pretty tired and I'm mostly going to let the chat carry me. So, although... So, what we're going to first do is we're going to say every integer, let t denote the set of non-perfect powers. Then every integer is uniquely of the form like t to the n for some t and n positive integer. Unless it's 1. Okay, so well, let's just throw out 1. A equals b equals 1 word. Solution, ignore, henceforth, assume ab greater than 1. Okay. So let a equals if a equals s to the power of m and b equals t to the n, then this equation is given explicitly by, let's see, s to the m times b squared equals t to the n times... Well, we'll substitute b. Let me follow this through because I want to see what happens. This feels almost too good to be true because it tells me that A and B are powers. Am I crazy? This seems like a little too good to be true. But it like seems to suggest that A and B should have the same quote-unquote base. Really? I guess it's just that you're dividing out the GCD of the... Okay, so hence S equals T, and we have okay, now we have this. So A and B are powers of like you pick some T in capital T, you'll have the same power, and now they're supposed to satisfy this equation. M and N are random integers. Yeah, it looks like M over N is a power of T for sure. So in fact, it's like given exactly by... Okay, so we can let like... So M is still a random integer, but now N is exactly like T to the E M for some E, and 2 times T to the E M minus M is equal to E. Or E plus M equals 2 T to the E times M. Yeah, this feels like there's no way that is going to be true. Unless, like, it could be E equals 0, actually. Oh, actually, E could be negative, so, okay, things are a little stranger. But we can, yeah, we can let N is T to the EM. E could be negative, but this is always... T to the EM is always promised to be an integer. So, if E is greater than... So, this is actually pretty bad. So, if E is positive, A equals B to the X, or B equals A to the X. What? Okay. I want to finish chasing this because I want to see what happens, but I suspect that we are probably actually pretty close to done. Yeah, so if E is greater, like this should also just do it. So E if greater than 0, then 2 to the E times M is definitely bigger than E plus M, because it's bigger than 2E times M greater than E plus M. Yeah. That's a true statement. If E equals 0, we have M equals N, and actually M equals 2M contradiction. So that's actually not good. What if E is less than 0? If E is less than 0, then 2T to the E... Well, let's say if E is less than -1, then 2T to the E M will always be strictly less than M. Ish. I think E equals -1 is probably the most interesting case. Let's see. Okay, so if E is less than or equal to -2, I want to say this is always true. It might barely not be true, actually. It's definitely... I think it'll die if e is less than or equal to -3. 16,2 works? Okay, we finally found it. That's 4,1, right? That corresponds to t equals to... Yeah, e equals -2. Cool. So it's still within what I have. Yep, so apparently we have 2 over t squared times m equals m minus 2. And if m equals -1, we have this equation. So I want to solve both of these for over integers. And I don't think there should be solutions for e at less than or equal to -3, because then this is at least m over 4, and also m needs to be at least t to the e. T to the minus e. Yeah, it's actually quite... The signs are super confusing. But, let me make sure I got that right. If e is super negative... Nope, I missed this stuff. This should be minus e. But this is certainly true. T to the minus e minus 2. Okay, so that's fine. Alright, so that leaves us just, yeah, this is definitely okay. So we have 2 Diophantines, we just need to solve both. These 2 Diophantines, I just need to solve both of them. They should be pretty routine to solve. So 2m equals tm minus t. So if I solve for... Do I want to solve for m or t? What's better? Let's solve for m, because I think that t is probably 2 in every solution. So m is equal to t over t minus 2. This is promised to be an integer. Wait, did I screw that up? Tm equals 3 or Tm equals... So t equals 4 is technically not allowed, but I expect this... I don't think I really use this fact, so I expect it to give me a solution anyways. Yeah, I definitely want to solve for m and not t. So m is equal to Okay, so this is t squared minus 2. So this only happens if t squared minus 2 divides 4. Sorry, this is the same equation except t has been replaced with t squared. So for t squared minus 2 to divide 4, you need t squared equals 3, which is not possible. T squared equals t equals 2, which is possible. So t equals 2 and m equals 1. Or m equals 2. Yeah, so it's the same equation actually. Wait, I could have solved. That means I could have just solved for t to the e to begin with. No? Oh, I see. There's the e pops up here, I guess, is what's happening. Nah, whatever. So I probably did a bit of unnecessary work. But 4, 6. Okay. So that means the only solution is like given by this one. This one doesn't technically count, but it's the same as that. So m equals 2, t equals 2, e equals minus 2 gives someone extract the answers for me. 9, 3. There's a third because we got 3. Yeah, is it 9 comma mn? Okay, I'll work this out slowly. Like this one gives a solution, and then these two are solution, like the same solution. We can technically throw this one out. So 3, 3 is m equals 3, t equals 3, n equals 1. Yeah, so this is the 9, 3. Or sorry, 3,9. And the other one is 2,16. No, not 9. What is it? T equals 3, m equals 3, n equals t to the e times m. So n equals 9. 3 cubed 3 to the 9? Wait, it's that big? No, 3, 27, 3. Yeah, there we go. This would be 16, comma 2. Yeah, calculation's hard. I'm glad this is a situation where like all the steps, like throughout the entire solution, every step is reversible. So I know if there's a pair here that corresponds to the solution. And I just need to not mess up in calculating what it is. T equals 3, m equals 3, a equals t to the m, right? So it's just, yeah, I should just be able to write it down. 27, 3. And then 16, 2. Doesn't 2, 2 work? Does 2, 2 work? No. I don't think it does. Yeah, and also, well, I wrote a equals b equals 1 here already. I was doing just a equals b greater than 1. I did not forget about that. 1, 1. Alright, we did it! Okay, now can we do CMIMC problem to make it 3? Am I going to get it? it's computational geo, I honestly feel like I'm more scared of. Like if you told me here's a geo, it's like MO problem 1, I'm like, okay, that should be fine. If you tell me it's a geo and it's like hard computational geo, then I'm actually kind of scared. Have you done any inequalities today? So I'm taking it you weren't here when I did upside down triangle sure. Twice. Yeah. Okay, wait, let me do the YouTube outro, or something. Yeah. No, just forget it. Oh. Yeah, we did an inequality and it took 2 hours of me. Because the problem was the original problem looked like this, and I was just like, what am I gonna do with this? And very slowly figured out a way that I could actually solve it by hand without like squaring an obscene number of times. Alright, okay. Alright, we'll try to make it 3. So we'll see if... It's a conditional computational geo, and I have the feeling it's probably like number 8. So here we are. Yeah, we're gonna do another problem. I'm too tired to think about chess puzzles, I'm sorry. You can suggest it next time. Alright everyone, welcome back. Today we have a problem from the Carnegie Mellon Informatics Contest. It's a geometry problem, so I'm gonna pull up my GeoGebra and we'll see what we have today. So, we're given a triangle ABC. And the circumcenter of this triangle is O. And Q is the it's where the A altitude intersects the circumcircle. But we're just gonna pretend that it's the reflection of the orthocenter over side BC. So I can write it this way a little more concisely. Okay, and what the problem asks for now is you take the circumcircle of BOC. So probably we'll just do it. Circle BOC. BC, DE. Okay. So let's get the center of that circle so that I can construct the other intersections. So we'll call the center S for now. I might rename it in a bit. And D is the reflection of B over the perpendicular line from S to line AB. And E is the okay, so B, C, D, E, like so. And we're going to say suppose AQ, BC, and DE are concurrent. So they're not in this picture. But something. And then it gives you the lengths of OD and the length of OE. And you want to compute AQ. So it's AC and D. Oh, did I flip D and E? Sorry, I flipped D and E. Okay. Yeah, so there's a radical axis thing happening where if these things are actually concurrent, and let me find a picture where they are. So I'm going to move A around until there. If they're concurrent, then by radical axis, that tells us A, Q, E also lie on a circle. So color that. And of course the picture's not perfect, so D is like barely off the circle. No, get back here. There we go. Anyways, it looks like we'll care about the foot of the altitude either way. So we'll go ahead and name that L. Okay, so Twitch chat is suggesting that ADE is similar to ABC. That's always true just because it's a cyclic quad. So that bit is fine. However, it would be nice if AQ was actually the diameter of this circle, right? So let's see if that looks plausible. My GeoGebra isn't... Okay, so there's a pretty good chance I think that Q... Okay, we think that one is very likely to be diameter. What would need to be true for that? EBLQ cyclic. Oh, is it EBLQ cyclic? Okay, I believe that. So, if condition true, we get a EQD cyclic by radical axis, but also, let's see. Yeah, so directed angle BED is equal to directed angle BCD is equal to directed angle BCA, BQA, BQL. Okay, and the reason this looks so familiar to me is this tells you that DLE is the Simpson line from Q to... So what's really happening is that where like you have the Simpson line. So maybe it's better if I... So far we actually haven't really used O, right? Yeah, so I think it's actually better if I redo this problem the other way. We'll say let E be the intersection of the foot from Q to AB. Yeah. Freaking... Yeah, we'll let E be the foot from Q and D be the foot from Q to AC. We'll define it that way. DE is always a straight line passing through L, that's the Simpson line. And yeah, then as I vary A, its BOC might change. So actually, I take back what I said about S. I don't want S right away. But this circle... No, this circle? Yeah, so unconditionally, it's always the case that if I draw the Simpson line, it'll be cyclic and so on. And we're interested in triangles for which this BDEC also passes through O. I think that's a good way to think about it. So the Simpson line is all set, and we just want it to pass through O like so. So if it does, then there's other points it passes through. For example, it passes through the intersection of two tangents. That point. All right, and you're given OD and OE, which is weird. So, let's see. No. Nope. Is O the orthocenter of AED? Oh, that's actually a really good guess. Yeah, so O always lies on the A altitude of ADE unconditionally. What is this circle? This is this blue circle. Sorry, what's the black circle? It's like from ADE's perspective, I took this thing, dropped this foot. Okay, let's draw the orthocenter of ADE and see where it is. Yeah, AO is always perpendicular to ED. Why is OD perpendicular to AB? Wait, why is that true? If it's on the circle, then is DO... For this to be true, for this to be orthocenter, I need DB equals DA, right? Why is that true? This angle is that... Okay, I agree that's true. Actually, so this actually means... Really? DO... It's not always perpendicular. But if it's on the circle, then DO... OA equals OB, and then D... ECD? ECA... That just tells me that one is perpendicular if and only if the other is. ODA equals OBC. Why is that so? Oh. Wow, okay. So if O is on the circle, then directed angle OD is ODC's OBC. That's actually good enough because this is 90 minus A. So that's enough to get the perpendicular, like DO. So DO is actually the perpendicular bisector of AB, and similarly for AC. That's strong. Okay, so I have orthocenter. O is the orthocenter, and I'm told like OD and OE are in so-to-so ratio. I guess at this point it would probably be prudent to draw H equals triangle center ABC4 as well. Which is hidden for some reason. Okay, so what do I do now? Why is the extraction AQ? That seems like a strange thing to extract. AQ is the circumdiameter of the big circle, or the blue circle. So it would be sufficient to get the circumdiameter and also the ratio of similarity between the two. Thank you. I said for the vote. Oh, actually, hang on. Okay, so OD and OE correspond to like the... Okay. What's the result about AH squared and... Okay, so... Yeah, so how does it go? OE squared is AQ squared minus... Oh, it's 4R squared minus the side length squared, right? So OD squared is equal to AQ squared minus AD squared. And OE squared is equal to AQ squared minus AE squared. Okay. Do I know AD squared plus AE squared? I doubt it. Can I get like 80 squared plus 80 squared or somehow? QEDO parallelogram. Are you serious? That's okay, that is a true statement. QEDO's parallelogram! That's good to know. Does that tell me anything I didn't know before, actually? I feel like that doesn't give me any new... It means I need to get DE. Like, if I get DE, then I win. Wait, actually, hang on. What? DE... So DE squared equals... So parallelogram thing says that DE squared plus OQ squared, which is a quarter A... no. OQ is the... radius. Okay, whatever. Radius of the original, so... Equals 2 OD squared plus OE squared. So I want to relate OD, OE... OQ... No, OD. Which things don't I know? I don't know OQ. I don't know AD, and I don't know AE. Yeah, I don't freaking know. So if I get, like, I need to get ADAE in... I wonder if I can do something with a Simpson. So getting the answer is equivalent to getting AD, or AE, or DE. So actually, if I know what the answer is, then you can extract the values of all the sides of triangle ADE. And so you know ABC up to similarity as well. So I should just go for any side. Actually, no. Sorry, I take that back. OQ is not particularly... OQ is the radius of the original. So that parallelogram equation actually is the one that has two things we don't know. We don't know DE and OQ. I just need, like, any relation between OD and OE. Like, or not OD, or no, AD and AE. Like... AD divided by AE is AB divided by AC. Like it would even be enough to get like AB over AC at this point. I don't see. Or equivalently ED over BC. So AD is equal to DE. That's actually worth noting. Like AD is equal to DE and wait, what? No. AD is equal to BD. Sorry, that's what I meant. B is a perpendicular bisector. Okay, so let me make a note of that. It's also equal to AQ squared minus BD squared, and AQ squared minus CE squared. Okay, so it's like, can I get a relation between like BD squared and CE squared? Like anything. Maybe that's going farther. It's also like, okay, so like AD is given exactly by this is why I'm scared of computation. Yeah. AD is given exactly by AQ sine C. And AE is given by AD equals BD equals AQ sine C, and AE equals CE equals AQ sine B. Isn't OT equal to AQ? Wait, it is. Orthocenter equal radius thing. Oh, you are right. Okay. Yeah, the blue and black circles have congruent radii, so OT is equal to AQ. Okay, so actually I just need the radius of the black circle equivalently. Yeah, so we have a parallelogram, so QT is actually exactly equal to the radius. I mean, I could compute TE and TD. That's not great. I agree DE is equal to AQ times sine A. And OA is equal to AQ sine A? Wait, is AETD? Are you serious? Okay. Yeah, that's gotta be true. Yeah, okay, I agree AATD is a parallelogram. I just don't, like, yeah, how do you do the extraction? OA squared plus DE squared equals AQ squared. Yeah. Yes. Wait, no, what? How? Oh, yeah. No, I think I wrote that down. Maybe I didn't. Yeah, so that from the A squared minus 4 string, A squared minus DE squared. Yeah, okay. I'll write this. D squared is like OA squared minus AQ squared. Oh, did I screw up? Okay. D squared is equal to... Yeah, AQ squared. Aren't we done? Wait, what did I miss? How do you finish? I don't see how you do the extraction. I see a bunch of equations. Like we have these. It's not like these 4 equations are going to... If you put these together... No, because you have a stray variable OQ. Because it's equal to OA. Oh, is that actually enough? Like, do they... Are you serious? Wait, I didn't need the first two. What the heck? Oh. Alright, fine. How did we miss that earlier? I mean, I definitely knew that this equation... I guess I just didn't consider it because I was like, OQ is an extra variable. And OA is also an extra variable, so I didn't really want to push them. But you can set them... They just happen to give the same equation, so it's like, okay. Yeah. No, this just works. There were 2 straight variables, and I didn't think they would just, like, knock each other out. Even though they're equal, like the DE also just goes away. Isn't it 1 AM? Yeah, it's been a long day. I mean, I started the stream at 10 because I had a meeting beforehand. But yeah. Alright, we did it! One more computational geo done. What? Yep, this is good. Alright, hope you all enjoyed DJ's problem. Thanks for coming by. See you next time. Do 3VT's puzzle. Next time. I'm tired. I could probably solve it right now. Okay, I'll look at it. And not try very hard. Where is it? So, how does this work? The engine is wrong. I don't know what how this website works. How do I turn off the engine? This thing? Show thread? Or how do I turn off the engine? Is the better question. Top right. Is it just this thing? Local. Okay, whatever. Okay, so what am I trying to do? Mate in 40. So I need to checkmate the white, black to move. Black to move. Queens cannot move. Mate in 42. Okay, so. Alright, so how does this go? So White King is about to be stalemated, unless I do something real soon. Most pieces can't move. Wait, I don't even see how the first move works. Like... Does it tell me if it's... Wait, I don't understand how this works. Isn't it supposed to, like, not let me make illegal moves? Oh. Oh, right. Wait. No. What?
Wait, Evan, black pawns move upwards.
Oh. How did the board... Okay, fine. Alright. So... Okay, so... Black to move... The board is oriented such that the pawns go up. I need to checkmate in 42 moves. I can't move any queens. And also... There's only like two legal... There's only one move I can make, right? Is that... Right? I agree it makes sense now that you mention it, but like I would never see a reason why the white king should be on square h8 with 60 other black pieces. Yeah, there's not that many possible moves. So I just move this. Am I missing a possible moves?
No, Evan, you're on the right track.
Okay. Alright. I feel like every step there's like one unique move that isn't the previous one. So how many moves has it been? 14. Wait, does 42 mean like 42 total or oops? Oh shoot, that's the first time there's a decision to make. Okay. Rewind. What's going on here? Apparently I'm supposed to checkmate the white king. Also, this is h8, so pawns move up. This was not clear to me. Initially. Okay, so if I move this, hang on. So okay, that's forced. That's forced. That's forced. I could move this rook down, but that would cause. What happens if I move this rook down? Okay. Am I just reverting what I did before? I don't actually remember what I did.
Yeah, Evan, you're kind of reverting.
Alright. It has to be the bishop chain, right? Ah, I have to make a choice. Will queen scrap move? I'm stuck. You know, let's try that. Nope. No, no. Actually, hang on. There's a knight here. I didn't notice that earlier. Oh, okay. If I move the knight, now this piece can promote. Right? Oh no, I have to make another choice. No, I think I want a knight. Like, the pieces are stuck enough that, like... okay. Alright. Does that unlock anything? Unlocks the Black King. Haha. What can go here? Uh-oh. Oh, that's not good. Okay, so... Oh, no, it frees that knight, I see. So this knight can go now, and now this guy can go, and this guy can move. Go. Okay. You go here. You go here. I'm running out of turns. You go here. I need this pawn column is what's really the problem. I need to get the black bishop to move. So that this... Am I going to make it in time? How many turns has it been?
You'll make it in time, don't worry.
Oops. That's not how you check reading. Okay, wait. Let me rewind. So I definitely want the pawn column. Oh. Okay, is that checkmate? Or, yeah, I can't move. Alright, we did it. The objective was to checkmate the king in 42 turns, and we got it in exactly 42. Without moving queens. Yeah. Okay. That happened. That was not as bad as I thought it was going to be, because like most of the time there's only one move you could make. Is this going on YouTube? I guess so. I probably didn't do the intro properly though, because I didn't actually think I was going to solve it. I was just like, I'll give it a look, and then it turns out there was like only one thing to try for the first like 10 moves. Yeah, so I'm gonna have to put like the title as like checkmate white in 42 moves without moving queens. And then the thumbnail is gonna be this board. Or something? I don't know. How do I go back to turn 1? Yeah.
Wait, Evan, if you didn't notice, your promotions didn't matter.
Yeah, I noticed. I thought they might because, I don't know, it feels like if I was designing the puzzle, I would make sure that the promotions mattered, but it didn't look like there was a way to force that to be true in this. Yeah. Making a promoted piece move is backtracking? I don't know if that's... Is that true? I guess that might be true. But it feels like you might be able to move to a different square. I don't know. I guess it shouldn't matter, yeah. Alright, cool. We're done. Alright, thanks everyone for coming by. Hope you all have fun. There will probably be no stream next week because next week I will be in the middle of Mystery Hunt, which you should all totally do. Yeah, for those of you that haven't seen, this is the Mystery Hunt website. You can literally just sign up, even if you don't have a team. You can just fill out a form and then get attached to a team. Yeah, it's gonna be great. I have put way more hours into this mystery hunt than I will ever admit, and I'm not one of the main organizers. I'm like just a minion, so we put a lot of time into this. It's gonna be great. Come through. Yeah. All right. Alright, thanks for coming by. Probably see you in a couple of weeks. And yeah, that was pretty cool. See you all. Yeah, time flies, you know? A hint for Anna on Banana and Otis app. You should write down a lot of examples of words that work and words that don't work. Like, for example, Otis is a word that works, and A is an example of a word that doesn't work. And if you do enough examples, I think you'll be able to at least figure out what the answer is. Okay, see ya.